my name is Hannah. Welcome back to another Facebook Live at the Arizona Science Center. So for this week with our virtual Calling All Scientists camp, today we are talking about the earth sciences. And I want to highlight a particular career related to the earth sciences, which is a materials scientist or engineer. So today we're going to be learning a little bit about the history of concrete and cement. And then we're going to be doing kind of an engineering test of some different types of concrete pucks that I reinforced with different materials. So first of all, a little bit about the history of concrete and cement. So cement is a ceramic material that is actually pretty breakable, but when you add in or mix in things such as sand or gravel, that's what creates a composite, which is what we call concrete. Now, the use of concrete goes back into ancient times. A lot of us think of the ancient Romans when we think of concrete, but it was also used by the ancient Egyptians and by the ancient Greeks, and also by the ancient Maya here in the New World. The ancient Romans are the most famous for their concrete because they made some of their architectural wonders with their particular kind of concrete, such as the Colosseum. And in fact, the Roman Pantheon is known as I gotta check my notes for this one. Yes, the world's largest unreinforced concrete dome. So that's pretty cool that the Pantheon kind of stood the test of time in that regard. So the last kind of important update on the history of concrete that I wanted to share with all of you was the invention of Portland cement. That is one of the most common types of cement that we still use today. And in fact, that's the kind that I use to make my concrete pucks. That was patented and invented by a British engineer named Joseph Aspdin in 1824. All right, now one safety note. So whenever you do anything with cement or concrete, especially if it's in its powder form, you want to make sure that you're wearing goggles, gloves, and a mask, which hopefully we have plenty of those around these days. I'm not wearing those things because I already made my pucks and they are dry, but if you are in the process of making cement, I suggest those safety considerations. So what we're going to do is we're going to, again, use our engineering design process here to go through how we would make cement pucks and test the different materials that I reinforce them with. So first of all, our question that we're trying to ask today is, how can I create the strongest cement puck that I can drop from a height of 1 meter? We're going to be doing that a little bit later in the call. And how can we think of materials in the natural world that we can mix in with that concrete to strengthen it? Now, our brainstorming stage is, again, thinking of those materials that we maybe could use, and then we come up with a plan, which materials we would like to test, and then we create our pucks. So if you would want to make these pucks at home, what you're going to need is, again, powdered, ready to set Portland cement. You're going to need some styrofoam cups. So for example, if you take this styrofoam cup, what you're going to do is you're going to take some scissors and just cut off the lip of the cup, like I did here. And this is going to create your mold for your cement puck. Then you're going to take some duct tape, like I did, and put it on the bottom. And then you're going to cut the duct tape around and kind of seal the edges. It's important to seal the edges, otherwise you might have liquid concrete spilling out. Then you're going to take some Vaseline, and you're going to just put a little bit of Vaseline basically at the base of your mold, and that helps you take the puck out once it's ready to dry. So with all of my pucks, I already took them out of their molds and they are ready to go. So we're going to go ahead and move on to the testing stage of our engineering design process. So I have a bucket at the front of my table here, and I have a meter stick here. What I'm going to do is I'm going to take each puck and I'm going to drop it into the bucket from the top of this meter stick, so 1 meter. Now, I will let you know that if I've actually not done this experiment before, or this materials test. So if we have the results that none of them are breaking from a distance of 1 meter, what I'm going to go ahead and do is increase the distance that I'm dropping it from, and then we'll try it then. So I'm going to go around to the other side of the table here to our bucket. Now I'm going to start with our control. Now in any kind of experiment or test, the control is the thing that stays the same. It's your constant. So my puck that is my control is, these are a bit ooey gooey because there's Vaseline on the bottom still. is just simply concrete. So I did not add anything to this puck. So let's give that one a try first. So I'll place this here, and then I think I'm going to drop them from this position here. We'll see what happens. Okay, so that's telling me that I need to go a little higher. So let's see here. I'm going to switch my meter stick for these 2 yardsticks. And I'm going to drop them a little higher. Now, if that doesn't work, then, you know, maybe we'd have to go to the top of a building or maybe to the top of some stairs. But we'll see what happens. Okay. So I got 2 yards here now. Let's see here. Okay. Well, we got some breakage there. It did hit the edge of my container there, so that might have been partly why. But I'll go ahead and keep going, and we can compare our results at the very end. All right, now this next one, I added steel wool inside. So that would be a man-made material. Oh, that one had no breakage at all. In fact, it sounded very solid to me. Okay, next one I'm trying is earth and soil. I apologize if I missed the bucket. Okay, so that one did pretty well. There's a little bit of breakage on the edges, but also pretty solid. It looks like all of these are going to do pretty well. All right. I'm going to have to do a big finale here. We're going to have to get one of these to break. Okay, let's try our cheesecloth. All right. Now, my last one is actually made of mystery fibers. If you want to in the chat, you can try to guess what these fibers were. I actually don't know because someone else in the Science Center made it. But if you want to guess what those mystery fibers are, go ahead and tell us in the chat. So I'll test this one out. And then I'm going to have to go big here for our last test. Oh, okay. Well, that's interesting. So that one definitely broke. And what I'm thinking is that this one is actually older. So this cement or concrete is older than all of the other ones. So I'm wondering if that's affecting the fact that it broke or not. Okay, now let's go big here. I'm going to go ahead and get on a chair. And I'm not going to measure this time. I'm just going to drop it from as high as I possibly can in the room here. Move this bucket out of the way. Get my chair. Now, in the chat, I would love it if some of you tell me which one would you like me to test. Okay, so we can probably test maybe 1 or 2 from this top height. Which ones would you guys like me to test? I'll just pick if we don't get any answers, but. No? Okay, that's all right. I'm going to go with, so based on my predictions, I think that the one that's reinforced with steel wool would be extra strong, so I'm going to test that one. And in terms of weakness, the control one already broke a little bit. That was the pure concrete. I think I'm going to try out the earth and soil. I feel like that one might be more likely to break. So I'm going to try those 2 from as high as I can drop them, as high as my arms will go. First, I'm going to try the one that was reinforced with soil. Let's see here. Oh, okay, that one definitely broke. Going to get to clean that up later. Let's scoot that up out of the way. Okay, and now we're going to test our one reinforced with steel wool, as high as it will go. And that one broke as well. So the distance that it is falling and the force with which it hits the floor is definitely something that we need to think about. Now, if I was to make some improvements on these designs, I would probably think about, you know, the size of the puck. Would the size of the puck affect whether or not it would break at a greater height, or perhaps the amount of steel wool that I'm using?
We do have someone who would like to see the control.
Oh, okay. All right, let's try it. Yeah, we had a little piece break off of the control, but let's see here. Let's see if we can get it smashed real nice. there we go.
Yeah.
That one just smashed into all kinds of little pieces. Another factor that I'm thinking about is that I was using a plastic bucket at first, and I'm wondering if the puck falling into the plastic bucket versus the tile floor probably has some kind of impact on this as well. Well, this has definitely been an experiment. This is actually the first time I've done this experiment, so thank you guys for learning with me. And if you want to check out more hands-on science, definitely check out our future Facebook Lives. Tomorrow we're going to be talking about we're going to be doing an experiment related to pharmacology, or how new medicines are produced. And then also check out our website at azscienceCenter.org.
azscience.org.
azscience.org. Sorry about that. All right, everybody. See you later.